Hi everyone, this is example 3 from chapter 17 in your student packet. It says, do people who work for a nonprofit organization differ from those who work at for-profit companies when it comes to personal job satisfaction? Data collected from 422 employees at nonprofit organizations revealed that 89.3% of them were highly satisfied. From the for-profit companies, 83.2% of employees reported the same level of job satisfaction. And I added this out of 518 employees because I realized that second sample didn't have a sample size. So we have two samples here, and the sample proportion is calculated for both of them. So we are going to run a two proportion z-test comparing these two samples. Before I do that, I want to talk about the conditions and assumptions that need to be met. So we need to assume that both of these samples were taken randomly. It does not say that it was in the problem, but it should. We also need to make sure that the samples are independent from each other, that there's no crossover. There's no person that was in the first sample and the second sample, and no relationship between anybody within the samples. So I think we can assume that since we're talking about people working for different companies here. We also need to check the 10% condition for both, and since we have millions of people in this country, I'm going to assume that 422 is less than 10% of the number of people who work for nonprofit companies, and that 518 is far less than 10% of people who work for for-profit companies. And then finally, we want to talk about the success-failure condition for each of these. So if we take 422 times 89.3%, we're going to get a success rate that's higher than 10. And then subtracting that value from 422, we'll get a failure rate of also higher than 10. And the same thing will happen when we look at the second sample. So I want to get into actually performing this hypothesis test. Now let's talk about the hypotheses. So the null hypothesis, actually, I'm about to talk about P's, so let's make sure that we tell everybody what our different P's stand for. So I'm going to let P1 equal the proportion of nonprofit employees that are highly satisfied, and P2 be the proportion of for-profit employees that are highly satisfied. So now let's talk about the hypotheses. So the null hypothesis, whenever we're comparing two samples, are that the samples are not different. The alternative hypothesis, in this case, they're asking if people who work for nonprofits, differ from. It's not letting me underline that. So since it just says is it different, not is it less than or is it greater than, we're going to use a not equal to here. So let's actually run this test. And before I do that, I know I'm going to need an X1 and an X2. So looking here, I'm just going to write out a little bit of work here. The P1 hat, my sample proportion from the nonprofit organizations, is 89.3%. And I want to write that as a fraction. So if I take 89.3 and I multiply, 0.893, and I multiply that by 422, I'm going to get 377 out of 422 is going to be my fraction. And I'm going to do the same thing for P2. So this is the sample of for-profit companies. And again, I'm going to take 0.832 and multiply it by the n, which is 518, so that I know that 83.2% is equivalent to 431 out of 518. And remember that when you're performing these tests, you need to have whole numbers with your fractions here. So if I go to Stat and Tests, and we are doing a 2-prop z-test, which is number 6, then x1 is going to be the 377, n1 is going to be 422, x2 is going to be 431, and n2 is going to be 518. And then we're looking to see if P1 does not equal P2. So let me put those in my calculator quick. And when we run this test, we get a test statistic of z equal to 2.69, which is pretty unusual, and a p-value of 0.007. And now I want to state my conclusion. I don't have a lot of room here, but I'm going to say that since the p-value is less than alpha equaling 0.05, I wasn't given a significance level, so I'm going to assume that it's 0.05. We reject the null. And conclude that there is evidence to suggest that there is a difference in personal job satisfaction between those working for profit companies and non-profit companies. I don't have a lot of room, so I'll keep abbreviating here. Okay, so let's actually figure out what the difference is between them. We see that there is a difference. What is the difference? So it says find a confidence interval and discuss whether it supports your test conclusion. So just like before, when we run a test, we're going to see that this information is already in the confidence interval that we're looking to find. So if we go to a 2-prop z interval, so we're going to go to Stat, Tests, and 2-prop z interval is way down there at B. And you're going to see that the information is already there. I'm going to have a C level of 0.95 since I used an alpha level of 0.05. Actually, sorry, I'm using an alpha level of 0.05, but this is a two-tailed test, so we actually have to switch this to 0.9. That's not something that you're going to need to know, but I am doing a 90% confidence interval. And I'm going to get a 90% confidence interval of 0.0247 to 0.09793. Now, what does this mean? This means that first of all, I want you to see that 0 is not in this confidence interval, which means when we're looking at whether or not P1 equals P2, when we find a confidence interval, we're actually finding a confidence interval on P1 minus P2. And so if P1 and P2 are the same, then when you subtract them, you should get 0. 0 is not in this interval, and therefore it rejects that null hypothesis that they're the same. Like I said, the confidence interval is based off of P1 minus P2. So because this is positive, it implies that P1 is greater than P2. And remember that P1 represents the nonprofit employees and P2 represents the for-profit employees. So what this is saying is that we're 90% confident that between 2.5% and 9.8% more people working for nonprofit companies have higher job satisfaction than employees working for for-profit companies. So again, this confidence interval represents the difference between these two samples.